I welcome you all in this tutorial. In this tutorial, I'm going to show you how to conduct the analysis of rigid flange coupling subjected to rotational velocity. So this is the coupling which is subjected to rotational velocity. Then the results of this analysis will be like this. So this is the result of maximum shear stress for this coupling. So you can see here the point of maximum and minimum stress, and this coupling is subjected to shear stress because of the rotational velocity. Similarly, the very important part of this tutorial is we are going to check the stress for each and every part of coupling, like the stress in the input flange, stress in output flange, stress in bolts, stress in input shaft, stress in output shaft, stress in output key, and stress in input key. So this is the main feature of this tutorial, where you can check the stress for each and every individual part of this coupling. So please watch this video till the end so that you can understand procedure to check the stress in each and every part of this coupling. So let us start this tutorial. So first of all, click on this geometry. So in this geometry, parts of this rigid couplings are shown. So like output flange, then this input flange. So this material of output flange and input flange is taken as grey cast iron because it is generally made up of grey cast iron. Similarly, the key of output shaft, which is shown here, then the output shaft. Similarly, the key of input shaft. So in order to see this key of input shaft, we have to rotate this model. So this is the key of input shaft. Then this is input shaft, input flange, nut number 1. So it can be seen from this view. This is nut 1, this is nut 2, then this is nut 3, and here it is nut 4. Similarly, for every nut there is bolt. So bolt 1, bolt 2, bolt 3, and bolt 4. So these are the parts in this rigid coupling. And the material of input flange and output flange is grey cast iron, and all the other parts like input shaft, input key, output key, 4 bolts and 4 nuts are taken as structural steel. The material for remaining parts is taken as structural steel. So let us go to the connections, expand these contacts. So here the contacts are developed between output flange and key of output shaft as a bonded type. Then second is output flange and output shaft is again taken as bonded. Similarly, so other contacts developed are taken as bonded. Only the contact between this output flange and input flange is taken as frictional, because if these 4 bolts get shear off, if these 4 bolts get fail because of the shear stress, then there would be chance of rotation of this output flange with respect to input flange, and there would be frictional contact between these 2 flanges. So we cannot take the contact between output flange and input flange as a bonded, so we have to take as here as a frictional contact. So other contacts are bonded type. So this is the output flange and nut 1, it is bonded. Again, this is output flange, nut 2 bonded. Then this is output flange, nut 3 bonded. This is output flange and nut 4, it is a bonded type of contact. This is contact between output flange and bolts, output flange and remaining bolts. So in this way, other contacts are taken as a bonded type of contact. So here you have to remember only one point in for this type of contact. So contact between output flange and input flange is taken as frictional type of contact, others are bonded type. Then right click on mesh and click on generate mesh. So it will take some time to generate the mesh. By doing this, we are discretizing our model into number of elements and number of nodes. So you can see the meshing is completed. Actually, I'm not going for on the fine type of mesh, just for by considering the computing time, to save the computing time. Okay, so now right click on static structural. By using this option we are going to apply the boundary conditions. Now right click on static structural, go to the insert, go to the frictionless support, and now we have to apply this frictionless support on the input shaft as well as output shaft. So for that purpose we have to select the geometry. So go to the face selection button, select this cylindrical face of input shaft, similarly cylindrical face of output shaft. So I have selected two faces of input shaft and two faces of output shaft. Now click on apply button. Now in this way I have applied the frictionless support on input and output shaft. Now right click on static structural again, go to the insert, go to the rotational velocity, and now we are going to apply the rotational velocity on the input shaft, to the input shaft. But here we have to define this rotational velocity either by component or by vector. So I am going to choose this option components. So now I have selected the option components. Now you have to select the value of x component, y component and z component of rotational velocity. If you look at this model, so this shaft axis is along x axis, so we have to enter the value of x component of rotational velocity. So I will enter here 1000 radian per second, and others will be 0. So you can see here, so this input shaft will rotate in this direction about x axis, as the shaft axis is along the x axis. Now I have applied the rotational velocity, I have applied the frictionless support to the both the ends of shaft on the cylindrical surface. Now I want to constrain the displacement of this model along the x axis, because there is a possibility of displacement of this model along x axis, so we have to restrict it. So again, go to the static structural, right click on it, go to the insert, go to the displacement. Now we have to select the face of this model to, so that its displacement along x axis can be restricted. So I will, as there is a possibility of displacement along x axis, so I will select the face button, I will select the face of this output shaft, and I will click on apply in order to apply the geometry. Then I will enter here x component of displacement as a 0 and others will be free. Okay, so I have applied the displacement on this end, one end of output shaft, so that its displacement along x axis can be restricted. Now right click on this solution and click on solve button. So it will take some time for the solution. Now once we get the solution, we are going to check the overall result for this rigid coupling. Remember that here we have applied the rotational velocity on the input shaft, so whole coupling is subjected to shear stress. So we are going to check the shear stress in this coupling. Now the solution of this model is obtained. So let us click on this solution, right click on this solution in order to check the output parameters. So as I have said, this coupling is subjected to a rotational velocity, which results into the shear stress. So shear stress will induce in this coupling. So let us focus on the shear stress for this model. So right click on solution, go to the stress, go to the maximum shear stress, right click on this maximum shear stress and click on evaluate all results. So it will take some time to solve this parameter, output parameter. So you can see here maximum shear stress value is 61.529 megapascal. So this is the overall result for this maximum shear stress for this coupling. So let us play this animation. So you can see how this shear stress is varying in this coupling. So now we have checked here maximum shear stress in the coupling. Now I'm going to show you a very important part of this tutorial. Now, as this is the result of overall result for this coupling, here you can see the maximum value of this maximum shear stress and minimum value. Okay, now we can check this maximum shear stress in each part of this coupling. So let us check the maximum shear stress in each part of coupling. So for that purpose you need to select that part whose maximum shear stress you want to check. So let us begin with the input flange. So for that purpose you have to select this input flange. So click on this body button which is here. So select the input flange. Now left click on this solution, then right click on this solution, go to the insert, go to the stress and select the maximum shear stress parameter. Now we have applied the maximum shear stress parameter for only input flange. Now we have to solve this. So right click on this and click on evaluate all results. So now this is the maximum shear stress for only input flange, where you can see here at this point there is a maximum value of shear stress, and here there is a minimum value of maximum shear stress. So shear stress is maximum at this point of this input flange, and it is minimum on this point of hub for the input flange. Now similarly I will rename this our parameter. So this is the maximum shear stress for input flange. Similarly, let us check the maximum shear stress for output flange, and let us check what is the difference between maximum shear stress for input flange and output flange. So we are going to check the maximum shear stress for output flange. So for that purpose again you have to select on this body button, then select the output flange, then left click on solution, then right click on solution, go to the insert, go to the stress and select the option maximum shear. Now we have selected the output flange for this maximum shear stress parameter, so we have to solve this. So right click on it and click on evaluate all results. So you can see here the maximum shear stress in the output flange. You can see here the value of maximum and minimum shear stress. So at this point, that is at the junction of this flange and hub, there is a maximum shear stress, and on the point of hub the shear stress is a minimum, that is at this point, and here the shear stress is maximum. So in this way we have checked the maximum shear stress for input flange and output flange. Now similarly let us check the maximum shear stress for bolts. So before that, edit this name here because this maximum shear stress is for output flange. So mention here the name of flange. So this is for output flange. Now similarly let us check the shear stress in the bolts. So let us select all the 4 bolts. So again go to this body button, select 4 bolts. By holding the control button you can select this all 4 bolts. Now so I have selected this all 4 bolts. Now left click on solution, right click on this solution, go to the insert, go to the stress and select this maximum shear stress parameter. So I have selected the 4 bolts for maximum shear stress parameter. Now right click on it and click on evaluate all results. So you can see clearly, you can see here the stress variation in the bolts. So here the shear stress is maximum at this point of bolt, and it is minimum at this point of bolt. So it is minimum at the free end and it is maximum at this point of bolt. So same variation of stress is applicable for all 4 bolts, that is maximum point of stress and minimum point of stress. So let us rename this parameter. So this maximum shear stress is for bolts. Now let us check similarly the maximum shear stress for input shaft and output shaft. So again, in order to select the input shaft, we have to go to this body button, select this input shaft, left click on solution, right click on solution, go to the insert, go to the stress, select maximum shear stress, and then again right click on it, select evaluate all results. So you can see here this is the stress variation in the input shaft. So you can see here this is the point of maximum shear stress and this is the point of minimum shear stress in the shaft. As you can see here, this is the point of maximum shear stress where the slot is made in the shaft for the keyway. So this is just because of the stress concentration in the shaft. Now similarly, you can check the maximum shear stress in the output shaft. Before that, rename this. So this is the maximum shear stress parameter for input shaft. Now let us select the output shaft for calculating the maximum shear stress in the output shaft. So go to the body button, select output shaft, then left click on solution, right click on solution, go to the insert, go to the stress, select the maximum shear stress. Then you can see here the output shaft is selected for this maximum shear stress parameter. Right click on it and click on evaluate all results. So our solution is ready for output shaft. Again, you can see here the maximum shear stress point is same as that of input shaft. Its location is same, that is the point at which the slot is present, that is the point at which there is a sharp corner in the shaft, and the sharp corner is present in the slot region of keyway, that is at this point, and the minimum stress in this shaft is here. So this is the point of minimum stress. Okay, so minimum shear stress is at this point. So this all blue color region shows that this is the area or the region of minimum shear stress and the maximum at the slot of keyway. So let us rename this parameter. So this is for output shaft. Now only the keys are remaining. Okay, so let us again select the key for checking the maximum shear stress in the key. So let us go to the geometry. Now as here you cannot see the key here, so just we have to rotate this model little bit so that you can see the key little bit, zoom it out. Now select the body button, select this key and left click on this solution, right click on it, go to the insert, go to the stress, go to the maximum shear stress, and you can see here it is turned into red color. So we have selected the output key for maximum shear stress parameter, right click on this maximum shear stress parameter and select the option evaluate all results. So you can see the maximum shear stress in this key. So it is maximum at this corner of this key, and it is minimum in this region where the blue color is present. It is minimum. So blue color represents the minimum region, minimum stress region, and this red color shows, that is this corner shows the region where the maximum shear stress is present. Now just rename this parameter. So we will write here, this is for output key, that is the key of output shaft. Now you can similarly check the maximum shear stress in the input key. So you have to rotate this model, click on this solution, go to the body button, click on this key. So key is selected. Now let us left click on solution, right click on solution, go to the insert, go to the stress, go to the maximum shear stress, then right click on this maximum shear stress and click on evaluate all results. So you can see the solution for this input key is ready, and you can see the clearly the point of maximum shear stress for key. So for this input key, the maximum shear stress is present at these two corners of key, and it is minimum in this portion of key, in this region of key where there is a blue color. So this blue color indicates the region of minimum shear stress. So this blue color shows the region of minimum shear stress. So let us rename this. So this is the maximum shear stress parameter for the input key, that is key of input shaft. So we have determined the maximum shear stress in all the parts of this coupling or rigid coupling. Now let us compare the values. So this is the result of overall coupling, that is maximum shear stress for coupling is 61.529 megapascal. Then this is the maximum shear stress for input flange, its value is 43.28. This is the maximum shear stress for output flange, its value is 49.164. Then maximum shear stress for all four bolts is 24.175. Then maximum shear stress for input shaft is 36.957. Then maximum shear stress for output shaft is 32.989. Then the maximum shear stress for output key is 61.529, and the maximum shear stress for input key is 58.667. So in this way you can check the overall results for this coupling, or you can go for individual parts of this coupling. So this approach will help us while understanding the nature of stress in each and every part. So thanks for watching this video. If you have any doubt related to this tutorial, you can mention in the comment section.